So welcome to video 3 of Simcenter 3D series. In this video, we will talk about the simulation file. In the last videos, we already have discussed about the part file and the FEM file. We'll discuss about the simulation file in terms of the applied loads, in terms of applying the boundary condition, in terms of finding the reflection, the stresses, and etc. Too many things are there. So I'll just take an example of a simple beam, and that beam I'll start from the beginning, making the model, making the meshes, and then making the simulation file, running it and solving it. So this will be the scope of this video. So for that, I have just made one cantilever beam of 60 by 60. It's a hollow beam basically. Outer dimensions are 60 by 60 and the thickness is 5 mm. So you can simple UG interface also you can save in a project folder, any folder you can make. In that you can make this beam. And then after making this thing, you can go for some length of any choice. I have gone for 600 in this case. And again, we are going to follow the same procedure what we have seen so far. So we'll go to application and then we'll go to the pre-post. In the pre-post, this will open as cantilever beam dot part. In this thing, we'll go to right click and then we'll create a new FEM. So it will also go in the same folder where you have made, and we'll go for Simcenter Nastran because we are doing the structural analysis. So structural solvers is basically Nastran solver. Okay. So we'll just keep everything as default and just click OK here. Now, as discussed already in the previous video, it will give us the FEM interface where you will make the mesh, will assign the material, etc. So we'll just follow what we have learned so far in previous videos, and then we'll check box this create idealize part and then click OK to it. So what we'll do is, first of all, we'll just go very simply here and we'll start assigning the mesh first of all to this body. We'll not do any, it's a simple model, so we don't have to go for defining this model any further. We'll simply go to the 3D tetrahedral mesh and then click here and then choose our body and then take the automatic element size. If it is recommending 25, I'll just go a little lower than that, around 15 or something. And then I'll go to here. If you see, there's a destination collector. In this thing, there's an automatic creation. We can check that. But what we'll do is, we'll create a new collector where we'll define all the things. So first of all, this is a solid. And in that case, you have to define the properties of solid. So we have to go for create physical. And here you have to define the material. So material, suppose I'll take aluminum 60661. So this is having a default library of the material list as well. In this, you have a library materials where all types of general used materials are there. In case you want to make some new material, you have an option here to create new materials also, where if you go there, it will ask you all the inputs basically what are required to create a material. So this interface will come where you can all add the density, the strength, the thermal values and all. So this is a discussion for the later subject. But yeah, so this is how you can make. For now, we'll go for aluminum 6061 and click OK. And we'll keep everything same. We'll just mention here aluminum beam. Okay. So if you click OK, you will see in the left side this simulation navigator is there. Here in the section of 3D collectors, this first collector will be made, which is aluminum beam, which we have defined the same properties. And in this thing, we have a 3D mesh, which what we have defined here. So our part of defining the mesh and all is over. Now comes the important part where we have to define the simulation. So we'll go to the FEM file and click on new simulation. It will again open, and then this time, if you remember, previously this type was .fem. Now this type is sim. So you will again go for Nastran, click sim file, click OK. And as soon as you open this thing, it will ask for some default window, new simulation, OK, and then ask you to create a solution. It will ask for a name, so we'll write beam 3D, and then solver is Simcenter Nastran that we can do. Analysis type is structural that we are doing. Solution time is type is solution 101 linear statics. That is what we are going to use. We have a lot of options as of now. Just ignore them. If you want to study about that thing, you can do. But for now, we'll go for solution 101. We'll come back to later 103, 105 and on later. But for now, we'll go for 101 only, and then create solution. Okay, so it will add it will open a solution window where every setting and parameters you can change, but we'll keep everything right now for default, whatever the configuration it is, and click OK here. Okay, now is the time where you have to define load and a boundary condition. Okay, so first boundary condition is, what we have to do is we have to define a fixed constraint. Okay, so I'll go take this face, suppose, click here and go to constraint types. So if you open that thing, you have multiple types of constraint: user defined constraint, enforced displacement, fixed constraint, fixed translation, fixed rotation. You have multiple options. Well, as of now, go for the fixed constraint and then click here, and it will ask for that body and click OK. So it will create a small sub case here, statics one, and that constraint will be visible here in this. In graphics also it will show here. All right, now second part side is where we have to apply the force. So we'll apply the force on this edge of the section. So what we'll go for load type and go for the force, and from the filter we'll select the polygon edge. We'll choose this edge, and then we'll specify the vector. The vector is positive x direction. That's what we'll choose in this x, and then we'll enter value of, suppose, let's assume some 1000 newtons load. So our setup is now ready. If you see, that will be highlighted on this part also. So it will come as like this. If you apply on an edge, it will show like force one on the linear edge, and then you have a fixed constraint. So that is all for the setup. Now simply we have to go and click solve. If you click solve, it will ask for a model setup check that you have to check, no issues, and then click OK. It will take very less time to solve this thing, and yeah, it will just run it, and then close it, close it. Then you have a new folder here which is called results. If you click structural, double click on this thing, you will be open with this post processing navigator, what is here. And then in structural, when you click, double click, it will show you by default what is the displacement. So what you can see from here, first of all, in this navigator, what you can do is, first of all, you can animate what is happening. So we were majorly applying force on the x direction. So we'll just take this YZ plane only, and we'll see how the deflection of beam is happening. So you can see things happening in the real time. If you go for displacement, you have four options actually: x, y, z, and the magnitude. So magnitude is basically the summation of all directions. Since it is a 3D beam, it will take and account for all. So if you go for x direction, which is the or major principal direction, it will come around 1.963 mm downwards. Okay. If you go for y direction, it is around 0.02. It is, if you go for around z direction, it is 0.146. If you take overall magnitude, it is coming around 1.969. So this is a basically deflection of the beam at the extreme end because of the fixed constraint and the load at the extreme end. So it will do all the calculations what we have studied so far in our BTech, MTech, whatever you have done. Wherever you have studied the strength of material, you have deflection formulas for the cantilever beams. It will calculate automatically based upon the defined cross section what is the moment of inertia, based on the material what is the Young's modulus, and all these properties is automatically does. Second thing what you can find out is here you can go for a stress elemental nodal, and you can go for one muscle stress. So we can see there is around 62 megapascal. The units also written here in the top side. 62 megapascal, 62 newtons per millimeter square of the stress is generated at the fixed end because of this applied load. So this is an overall, basically a full details of how the sim file works. And there are three sections just to summarize. First of all, there is a part file, and then from there we will make the FEM file, and from there we'll create the mesh as well as define the materials, and then we'll go to the sim file where we'll be assigning the loads, assigning the constraints, and there are many other things. There are many contacts that are gluing, which we'll be covering later in the sections, but for now we are just defining the very basic just to make sure everybody understands the user interface first. All right, so yeah, that sums up this video. Thank you.